Here we are trying to solve the following equations simultaneously. So we are given two equations, and we have two variables that we want to solve for, namely x and y. So we have a system of equations. Now, first we must isolate one of the variables, x or y. And fortunately, that has already been done for us over here. So all we have to do is plug in this expression for x into this equation, thus allowing us to solve for y in terms of x over here. So let's continue. X equals 2y plus 3. This might involve some algebra, so let's keep our hats on. 3, 2, y plus 3, all squared, minus 5, 2y plus 3, y, equal to 24 plus 16y. So let's expand all of this out. 3 minus, and this I think we can actually expand right now. So let's do that. That will be minus 10y plus 15, and we still have a y on the outside, equal to 24 plus 16y. So let's continue expanding. Do that and that. 4y squared plus 6y, this and this, 6y plus 9, minus, now let's do the minus and the y multiplied inside, so that will be minus 10y squared minus 15y, equal to 24 plus 16y. And then let's do our final multiplication. 12y squared 18y plus 18y plus 27 minus 10y squared minus 15y equals 24 plus 16y. Now it's just a matter of collecting terms. And remember, we still have this equal sign here. So if we ever take something to the other side, we must do its reciprocal sign or reciprocal action. So 12y squared minus 10y squared, 2y squared. So we've done these two. 18y plus 18y minus 15y should give us 5y. So we can get rid of the y's. Oh, sorry. Minus 16y. Yeah. That will still give us 5y. And then 27 minus 24 will give us 3. And that's all equal to 0 because we have an equal sign here still. All right. Now you can either use your silver calculator for this or the quadratic formula to solve this quadratic. I'm going to use factors instead. So we know that our quadratic is going to look something like this. But what we don't know are what these coefficients look like. And we do that by looking at what the factors of the constant are. And those are 3 and 1. So how can we put 3 and 1 in here somehow to give us 5? Because that's what we want to make. Well, there's a trick here. We don't have to worry about the signs. Because the constant sign is a plus, whatever the sign for the linear term is, which is just the y, will be the same throughout. So if there's a plus, for the constant, whatever this sign over here is, will be the sign for both brackets. So how can we put a 3 and a 1 here accordingly to make 5? Well, if we put the 3 here and the 1 here, let's try that. 2y plus 3y, that gives us 5y. That's exactly what we want. So we have factorized this quadratic. And then we just solve for y to make the entire thing equal to 0. So 2y plus 3 is equal to 0. Y plus 1 is equal to 0. Y is therefore minus 3 over 2. Y is equal to minus 1. But wait, we're not done yet. We still have x to solve for. And our original equation for x was x equals 2y plus 3. So let's sub in y. X equals 2 minus 3 over 2 plus 3. And that will give us x equal to 0. And then for the other equation, x equals 2 minus 1 plus 3, and that will give us 1. Therefore, this y and this x go together, and this y and this x go together. So our answers are x equals 0, y equals negative 3 over 2, x equals 1, y equals negative 1. And that is the problem solved.